Hello everyone, I'm Chini Ambarunday and today we're going to talk about how to convert decimal to binary, decimal to octal, and decimal to hexadecimal. First, let's focus on decimal to binary. Let's understand the basics first. In the decimal number system, we have 10 digits from 0 to 9. So these are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In the binary system, we only have two digits, the 0 and 1. So we are going to use 2 base 2 for the binary. So let's proceed to how to find a solution in getting the binary equivalent of decimal number 13. So I will teach you the easy technique on how to find the binary equivalent. First, we will start in the right side using number 1. Since we're going to talk about binary, we are just going to double up the number. So let's double the number 1. Doubling number 1 is the result would be number 2. Doubling 2 is 4. Doubling 4 is 8. And then if we're going to proceed to doubling number 8, it would result into 16. Since we are just going to find the decimal number, which is 13, we will not exceed to 16. We will not proceed to the next number. We will just stop at number 8. So in order for us to find it, we will add these numbers that would sum up to 13. So we will use first number 8. So we will write 1 under number 8. So we will add 8 plus 4 is equals to 9, 10, 11, 12. So 12. So we will put another number 1 under number 4. Since the result of these two numbers is 12, if we're going to add 2, it would turn out into 14. So it will exceed number 13. So we will put 0. However, if we're going to add 12 to number 1, it will result into 13, which is equivalent to the decimal number 13. So we will put under number 1, 1. So we will give a value to those number where we can sum up into a total of 13. So the binary number or the binary equivalent of decimal 13 is 1101. Now, I'll give you another example. Let's find out the binary equivalent of 26. So again, let's do the same process. 1, 2, 4, 4 squared, 4, 8, and then 16. So we're going to start with 16. Since the next number of 16 is 32, we will not proceed to 32 since we are just going to find out the binary equivalent of 26. So let's stop at 16. So 16, we will give a value to this number. So we will write down 1. 16 plus 8 is equals to 24. So we will put value 1 since it does not exceed 26. So 24. If we're going to add 24 to number 4, it will be 28. So since it exceeds the decimal number, we will put 0. Next number is 2. So 24 plus 2 is 26. So we will put 1. So we will automatically put under number 1 0 because if we're going to add it, it will be 27, which also exceeds the decimal numeral system. So To conclude, the binary equivalent of decimal number, which is 26, is 11010. So that is the easy technique on finding the binary numeral system. How to convert decimal to binary. Now, moving forward, let's talk about how to convert decimal to octal. So let's understand the basics. In the decimal system, we have 10 digits from 0 to 9. In octal, we have 8 digits from 0 to 7. So it's 0, 1, 2, 3, 4, 5, 6, 7 for octal, and its base numeral system is 8. So let's proceed with the example. We have 784 decimal numeral. So we need to find the octal equivalent of 784. Since it has 8 digits for octal, we will divide 784 divided by 8 equals 98. So it's whole number. Since it's whole number, we will write 98 remainder. The capital letter there, which is R, is remainder. It means remainder. And then we will just put there 0. Then we will copy the 98 whole number again there and divided it by 8, which is equals to 12.25. So there is a decimal um, point or a remainder. So we will write first the whole number and multiply 0.25 by and multiply 0.25 to 8. So 8 times 0.25 is 2. So we will write there 12 remainder 2. Okay? So we will copy again the 12, the whole number. 12 divided by 8 equals 1.5. Then we will copy first the whole number, which is 1, and then the remainder 8 times zero point 0.5, which is 4. So 1 remainder 4. And then we will copy again 1 divided by 8 equals 0.125. So we will put there 0, and for the remainder, we will multiply point 125 to 8. So 8 times 125 is equals to 1. So 0 remainder 1. So we're done with the solution. We will write the octal numeral system or the octal equivalent of the decimal number that was given. So we will start from here and we will write it in reverse. So we will write first 1, 4, 2, 0. And don't forget to put number 8 beside it because it represents that the answer is referring to octal numeral system. Okay. Next, how to convert decimal to hexadecimal. So in the decimal system, again, we have 10 digits from 0 to 9. In hexadecimal, we have 16 digits. So from 0 to 9, and then A to F representing 10 to 15. Okay? So first, I will explain this deeper after we have a solution so you will understand it. Let's have an example. The decimal number is 479. So we need to find the hexadecimal equivalent of that. So 479 divided by 16, since hexadecimal, is consists of 16 digits. So divided by 16 equals to 29.9375. So we will copy first the whole number, which is 29. And again, to find the exact remainder, we will multiply the 0.9375 to 16. So 16 times. So we will find the hexadecimal equivalent of this one. So 479 divided by 16 is equals to 29.9375. So we will write first the whole number 29, and for the remainder we will multiply 16 times 0.9375. So hexa the to find the hexadecimal of 479 decimal number, we will do this process. 479 divided by 16 is equals to 29.9375. So we will first copy the whole number 29, and for the remainder we will multiply the decimal number, which is 0.9375, to 16. So 16 times 0.9375 is 15. So 29, remainder 15. So we will copy again 29 divided by 16 equals 1.8125. So we will copy again the whole number, which is 1 here at the answer, and then multiply 16 times 0.8125 for the remainder, which is 13. Next, for the last one, 1 divided by 16 is equals to 0.0625 equals, so we will put here 0, remainder, 16 times 0.00625, which is equivalent to 1. So how are we going to write this in hexadecimal numeral system? So as what I have said, hexadecimal has 16 digits from 0 to 9, then A to F, which represents number 10 to 15. So what I meant for that is 0 is equals to 0, 1 is equals to 1, so on and so forth until the ninth number, which is equivalent to 9. However, when it proceeds to number 10, it represents letter A, 11B, 12C, 13D, 14E, 15F. So our answer, which is 1, 13, and 15. So we will start with the most significant number. So 1 is equivalent to 1. 13 is equivalent to D. 15 is equivalent to F. Represents F, rather. So we will, in writing the hexadecimal number or hexadecimal equivalent, we will start at the most significant number. So we will start at 1 and then DF. Let us start to most significant number to least significant number. So that's the end of my report. Thank you for listening and have a good day.